Chapter 3 Motion in Plane. Today we discuss the equations of motion for uniform acceleration. If the body attain or any object attain uniform acceleration or any body moving with uniform acceleration, then we find out the equations of motion, Newton's equation of motion, or it is also called kinematical equations of motion. There are three kinematical equations of motion. First, P is equal to U plus AT. Second, S is equal to UT plus 1/2 AT square. And third, P square is equal to U square plus 2AS. These are called equations of motion. Newton's equation of motion or kinematical equations. These equations are proved using graphical method or using graphical term we prove these equations. Now we using the velocity time graph. Suppose x-axis, y-axis. Origin 0, 0. Velocity time graph, that is x-axis. Along x-axis there is time. Along y-axis there is velocity. आज आपण इक्वेशन्स ऑफ मोशन किंवा कायनेमॅटिकल इक्वेशन यांचं प्रूफ किंवा ते कसे तयार झाले ग्राफिकल पद्धत आपण पाहतोय की स्टडी ऑफ मोशन युजिंग ग्राफ्स. आपण आज वेलॉसिटी, आपल्याकडे दोन प्रकारचे ग्राफ आहेत, पोझिशन टाइम ग्राफ आणि वेलॉसिटी टाइम ग्राफ. पैकी आपण वेलॉसिटी टाइम ग्राफचा वापर केला आहे. वाय ऍक्सिस वर वेलॉसिटी, एक्स ऍक्सिस वर टाइम, म्हणजे हा वेलॉसिटी टाइम ग्राफ आहे. आणि आणखी आपल्याला काय ऍड करायचे याच्यामध्ये, इफ द मोशन ऑफ ऑब्जेक्ट or object moving with uniform acceleration, that is its velocity is increases. If acceleration is uniform, its velocity is increases. Suppose this is up to that point, say that point is A. Up to O to A there is initial velocity, suppose U. At time suppose T. If T is equal to 0, the body attain initial velocity E. म्हणजे ज्या वेळेस टाइम 0 असेल, T is equal to 0, त्यावेळेस त्या बॉडीला, त्या ऑब्जेक्टला U एवढी वेलॉसिटी असेल. त्याला आपण काय म्हणू, initial velocity of body or object. At some time t, the velocity is increases. If time is t, its velocity changes to increases u to v. This is called final velocity. At time t is equal to 0, the object attained velocity u, that is initial velocity, and time is increases 0 to t, the velocity will be increases initial to final. This is the final velocity. Now, due to this, there is two shaded portion. The first shaded portion acts as a triangle, and second shaded portion acts as a rectangle. Now suppose O, B, C, D, these are the points. That is O, A, B, C, D is the total area covered by this object or particle, and that total covered area is nothing but displacement of particle from time 0 to t. Displacement of particle from 0 to t. Now, in graph, the body or object moving with uniform acceleration and body having position x is equal to 0 and t is equal to 0. In case of velocity, if t is equal to 0, body attain a initial velocity, that is u. If time increases 0 to t, its velocity is also increases, u to be called final velocity. And this increasing velocity is given in this graph, that is AB, and this AB or slope of line AB gives acceleration of the object. That slope of line AB, that is this line gives, or slope of this line gives the acceleration of the particle. Suppose this slope of line AB is equal to BC upon AC. But in figure, OA is equal to CD, that is, this is also initial velocity. This OT is T, or this OT is similar to, or OD is similar to AC, hence this AC is nothing but T. OA U, CDU, BD, this distance is V, then BC is V minus U. BC is nothing but V minus U. ACT, then we find out slope of line AB is nothing but acceleration A. The slope of line AB gives acceleration or acceleration is denoted as small a is equal to value of BC P minus Q, value of AC T. Therefore, phi minus u is equal to AT. Also, we find out value of T. T is equal to phi minus u upon A. Or finally, phi is equal to u plus AT. This is the different form of first kinematical equation or first equation of motion. Phi is equal to u plus AT is called first equation of motion. This is also called first kinematical equation, and this is the different form. Today we discuss about equations of motion. There is three equations of motion, and this is the first. We prove the first equation of motion, that is phi is equal to u plus AT. Now we go to another equation, the second equation of motion. In graph, the total shaded area gives the displacement of particle from 0 to t. That is, displacement of particle is equal to total area or total area covered by this particle. Suppose displacement is S, total area, that is area of that rectangle, suppose O A C D plus area of triangle ABC. This is the displacement of particle. Therefore, S is displacement. S is equal to area of OACD. याचा एरिया म्हणजे लांबी गुणिले रुंदी. लांबी आपण ही कन्सिडर केली, रुंदी ही कन्सिडर केली, तर काय येईल u, और we say that OA into OD. This is the area of OACD plus area of triangle ABC. हा राइट एंगल ट्रायंगल आहे, याचा एरिया काय असेल 1/2 बेस इनटू हाइट. बेस आहे AC, हाइट आहे BC. 1/2 बेस इनटू हाइट, और S is equal to OA into OD plus 1/2 base AC into height BC. Now S is equal to values of OA U, OD T plus 1/2 values of AC T, values of BC P minus A. From this equation, phi minus u is equal to A. Therefore, S is equal to ut plus 1/2 t instead of v minus u, v minus u च्या ऐवजी आता काय आहे, v minus u is equal to 80, इक्वल टू साइन आहे म्हणजे ही बाजू आणि ही बाजू सारखी आहे, म्हणजे v minus u च्या ऐवजी आपण 80 किंमत ठेवू शकतो, 80. Therefore S is equal to ut plus 1/2 a into a square. This is second equation of motion. This is second equation of motion. Now first equation of motion आपण पाहिलं, second equation of motion. आता इक्वेशन नंबर 3 कडे जाऊ. इक्वेशन नंबर 3 आपल्याला कसं मिळेल? In our graph, the body attained constant acceleration or uniform acceleration. Object moving with constant acceleration. That is, its velocity increases with time. जर बॉडीला acceleration constant असेल तर त्याची velocity वाढते with respect to time. That is, we get average velocity. Average velocity is equal to displacement of particle. Total displacement of particle. If velocity changes, we find out the average velocity. There is initial velocity u, final velocity v, then v average is equal to v plus u upon 2. आपण त्याला सरासरी म्हणतो. फायनल वेलोसिटी आणि अधिक इनिशियल वेलोसिटी भागिले 2 केलं तर आपल्याला एव्हरेज मिळेल. मध्य वेलोसिटी, दोन वेलोसिटीचा मध्य काढायचा असेल म्हणजे ह्या फिगर मध्ये जर आपण गेलो तर ही इनिशियल वेलोसिटी आहे सुरुवातीची, हे नंतर फायनल वेलोसिटी आहे, एव्हरेज वेलोसिटी किती आहे मग v plus u upon 2, and this average velocity nothing but total displacement. Then the displacement or using suppose average velocity, v average is equal to displacement upon time. Suppose this is S is displacement, therefore we find out displacement. S is equal to v average into t, or this gives, we put the value as v average, that is v plus u upon 2 into t. Now we put the value of t using first kinematical equation, that is v minus u is equal to 80, then we get value of t is equal to v minus u upon 8. Put the value of t, then S is equal to v plus u upon 2 into v minus u upon 8. Suppose this is first bracket, second bracket, v plus u, v minus u. This is very similar to a plus b, a minus b. That is, this is the using suppose mathematics, a square minus b v square is equal to a plus b, a minus b. Therefore म्हणजे तर b ची किंमत v, b ची किंमत u, म्हणजे च्या विषय काय येईल? s is equal to v square minus u square divided by a. Therefore this gives v square minus u square is equal to 2as. Or finally v square is equal to u square plus 2as. And this is the third equation of motion. V square is equal to u square plus 2as, where v means final velocity, u initial velocity, a acceleration, s displacement, and this equation is called third equation of motion. In this way we calculate or we prove the equations of motion, first equation, second equation and third equation using this graph or this velocity time graph.